smart learners. Our lesson for today is Rational Inequalities. The learning objectives for today are: you are expected to define inequality and solve rational inequalities. This is the learning pocket concept map, and we are going to focus only on rational inequality. Let us recall inequality. How do you define inequality? An inequality is a statement of two quantities. One is specifically less than or greater than another. The symbols used of inequality: we have the less than, greater than, less than or equal to, and greater than or equal to. We are using also an open dot, this one, or the parentheses. This is drawn on the number line if the inequality symbol used is greater than or less than. We are using a solid dot like this, or a bracket. This is drawn if the inequality symbol used in the given is greater than or equal to, or less than or equal to. Let us have examples. X is less than or equal to 11. So, we are using the solid dot. And you highlight from here, this is 11, going to negative infinity to represent x is less than or equal to 11. And this will mean that 11 is also a solution and all the values less than 11. Another example, we have x is greater than 11, and we are using the open dot. Then highlight from here going to positive infinity, and this will mean that 11 is not included, only the values greater than 11. Let us have another examples. We have x is less than 5 and x is greater than or equal to negative 3. Let us take this one first. We are using the close parentheses to indicate less than. Or if you don't want to write the close parentheses, you can use the open dot. And this will mean that 5 is not included, only the values less than 5. And for the other one, we have the open bracket. This will mean that negative 3 is included. Or you can use the solid dot. So again, this will mean negative 3 is also a solution and all the values greater than negative 3. To elaborate more, so this symbol, the close parenthesis, is similar to the open dot. And this open bracket here is similar if you will use a solid dot. This one and this one are the same, and also with this. Do you have questions? If there is none, let's proceed. Let us have rational inequality. What do you mean by rational inequality? A rational inequality is an inequality that contains one or more rational expressions. It can be solved much like polynomial inequalities. The symbols used are the same. We have the less than, greater than, less than or equal to, or greater than or equal to. Let us recall linear inequality. For example, x is greater than or equal to 5. X plus 3 greater than 0. And negative 2x plus 4 is less than 2. Let us also have examples of rational inequalities. 1 over x is greater than 2. And x plus 3 over 2 is less than or equal to 1. Let us solve now rational inequality. Let us start with the simple rational inequality. Let us now solve the simple rational inequality 1 over x is greater than 2. Take note that x is not equal to 0 or else the inequality becomes undefined. Solutions. For step 1, we have to consider two cases. First, x is greater than 0 and the other is x is less than 0. So for case 1, x is greater than 0. Using the given 1 over x is greater than 2. Then transpose 2 to the other side. So what we have now is 1 over x minus 2 greater than 0. And then simplify, you multiply each member of the inequality by x. So 1 over x times x, you cancel x. So what is left is 1. It's here. Then negative 2 times x is negative 2x. Greater than 0 times x is 0. Transpose 1, so you will have negative 1. And then divide by a negative 2, divide by a negative 2. The answer is 1/2. X is less than 1/2. Take note that the multiplier is negative, so you have to reverse the symbol greater than into less than symbol. And then for case 2, x is less than 0. This is the given 1 over x greater than 2. And then when you transpose 2 to the other side, you have now 1 over x minus 2. Then change the symbol less than because case 2 is x is less than 0. Then we have now 1 over x minus 2 less than 0. And then simplify the inequality, multiply each member of the inequality by x. So 1 over x times x, you cancel x here, so what is left is 1. Negative 2 times x is negative 2x. 0 times x is 0. Then transpose 1, so you will have negative 1. And divide by a negative 2, divide also the other side by a negative 2. So what is left now is x is greater than 1/2. Again, you will reverse the symbol into greater than symbol since the multiplier of x is a negative number. For step 2, you have to plot the resulting values of x in case 1 and in case 2 using the number line into intervals. So, let us have the number line. And plotting the open dot, this is 0 because x is not equal to 0, so we're using an open dot. And 1/2 for x is greater than 1/2, so this is open circle or open dot. And x is also less than 1/2. And divide the regions into 3. So this is region 1, region 2, region 3. And the intervals, this part will represent x is less than 0. This portion will represent x is between 0 and 1/2. And this region will represent x is greater than 1/2. So again, we are considering the critical point 0 and 1/2. 0 again, since x is not equal to 0, and 1/2 for x is less than 1/2 or x is greater than 1/2. For step 3, you have to test the values of x by choosing one number per region or per interval. So supposing we are going to use -1 on this region and 1/4 between 0 and 1/2. And on this region, we are using 2. 2 is greater than 1/2. So, we have to test the values at x equals -1. So, this is the given 1 over x greater than 2. 1 over -1, you substitute -1 to x. The result is -1. And greater than 2. Is -1 greater than 2? It's wrong, so false. We have a false statement. Next, at x is equal to 1/4. 1 over x greater than 2, that's the given. So 1 over 1/4 greater than 2. 1 over 4 over 1 greater than 2. Multiply, so 4 is greater than 2. And this is a true statement because 4 is greater than 2. And at x is equal to 2, 1 over x greater than 2. So 1 over x greater than 2 is false because 1/2 is less than 2. So, at x is equal to 1/4, we have a true statement. Therefore, this region here, all the values between 0 and 1/2 will give us true statements. And here, all the values less than 0 will give us false statements. And all the values on this region will give us false statements. Therefore, we have to highlight this region. Therefore, the solution set is equal to the set of x between 0 and 1/2, or we can write the parentheses to indicate that 0 and 1/2 are not included, so 0 and 1/2. This portion is read as the solution set is the set of real numbers between 0 and 1/2. Take note, if you will write in this form, this is the set builder notation. If you are writing in this form, we call this as interval notation. Do you have questions? If there is none, let's proceed. Let us solve rational inequality, by this time the complex rational inequality. In solving rational inequality, if the form is f of x is greater than 0 or f of x is greater than or equal to 0, then the solutions are all of the intervals with the positive sign. And if the form is f of x is less than 0 or f of x is less than or equal to 0, then the solutions are all of the intervals with the negative sign. The zeros of f of x are part of the solution if f of x is less than or equal to 0 or f of x is greater than or equal to 0. Let us have the steps in solving rational inequality, especially the complex rational inequality. First, simplify the rational inequality. Second, find the critical values or critical points. Then then plot the critical points on the number line into intervals or regions, and then test the values using f of x form, and construct the table of values, and lastly, graph the solution set on the number line. Let us have this example. Supposing you are asked to solve this rational inequality x squared plus 1 over x plus 2 greater than 2. So using this given, we have to take note that the f of x is in the form of f of x greater than 0 form. So we have to look for the positive sign later on. So x squared plus 1 over x plus 2 minus 2, because we transpose 2 to this side, greater than 0. And we have to find the LCD. The denominator of this is x plus 2. The denominator of negative 2 is 1. And the denominator of 0 is 1. So the LCD is x plus 2. X plus 2 divided by x plus 2 is 1. Times x squared plus 1, we have x squared plus 1. Then x plus 2 divided by 1 is x plus 2. Times negative 2, we have negative 2x minus 4. And x plus 2 divided by 1 is x plus 2 times 0, then we have 0. Let's simplify. We have x squared minus 2x minus 3, because we combine 1 and negative 4 over x plus 2 greater than 0. And then after this, we have to factor the trinomial x squared minus 2x minus 3. The factors are x plus 1 and x minus 3. So multiplying x times x, x squared, x times negative 3, negative 3, and 1 times x, positive 1, it will give us negative 2x. Positive 1, negative 3 will give us negative 3 over x plus 2. And with this, we can have the f of x form and write this expression. This one. Then, for the second step, you have to find the critical values using the f of x greater than or equal to 0 form. So with this, and this, at this time, you have to set f of x equal to 0. So you change this into 0. And then you can apply the symmetric property of equality. So you can interchange the position. So we have like this. And we have to set each factor or each binomial to 0. So x plus 1 is equal to 0, x is equal to negative 1. You transpose positive 1. And x minus 3, so x minus 3 equals 0, transpose negative 3, so you have 3. And for the denominator, x plus 2 is equal to 0, transpose 2, you have negative 2. Therefore, the critical values or the critical points are negative 1, 3, and negative 2. The next step, you have to plot the critical points on the number line. So, the critical values again are negative 2, negative 1, and 3. So, negative 2 is here, negative 1, and 3. And then you have to divide the regions. So we have region 1, region 2, region 3, and region 4. Then, this region has the interval x is less than -2. So all the values here are less than -2. And for this region, the values of x here between -2 and -1. And for this region, the values of x are between -1 and 3. And for this region, we have x is greater than 3. Next, we have to test values using f of x is equal to x plus 1 times the quantity x minus 3 over x plus 2. Supposing we are going to choose -3 on this region, and then -1.5 on this region, 1 on this region, and 4 on this region. So, solving for the test values using the f of x form, we have at x is equal to -3, you substitute -3 to x, this one, and also the denominator. So simplify, we have -12. At x is equal to -1.5, then change x into -1.5. Here, -1.5, and also the denominator, -1.5. Simplify, then we will have 4.5. At x is equal to 1, change x to 1, 1, and the denominator x, change it to 1. Simplify, then we have -4/3. And at x is equal to 4, then change x into 4, this one, and this one. So the answer is 5/6. And recalling the values, at x is equal to -3, the value of the function is -12. At x is equal to -1.5, the value of the function is 4.5. At x is equal to 1, we have -4/3. And at x is equal to 4, we have 5/6. Then the intervals we have x is less than -2, x is between -2 and -1, x is between -1 and 3, and x is greater than 3. Then for the table of values, we have to tabulate all the results. We're testing the values of x for -3, -1.5, 1, and 4. And the results of the f of x, we have -12, 4.5, -4/3, and 5/6. And look at the sign of the f of x. This is negative. This is positive. This one is negative. And the other one is positive. Therefore, we will be using this interval and also this interval, because this one gives us the positive result and also this one. Therefore, our solution set would be a combination or a union of this interval x between -2 and -1, and for x is greater than 3. So, sketching the graph of the solution set on the number line, then we will have to use the positive sign, highlight the region with the positive sign. This one will give us the positive sign, and also this one. Okay. And for this, it's negative. Here, negative. So meaning, you have to highlight this region and this region. Therefore, the solution set is equal to the set of x such that x is between -2 and -1. Union with the set of x greater than 3. This is the set builder notation. Or you can write in interval notation, then we have -2, -1. Then 3 to positive infinity. Do you have questions? If there is none, then let us recap the steps in solving rational inequality. First, simplify the rational inequality. Second, find the critical values or the critical points. Third one, you have to plot the critical points on the number line into intervals or regions. Then you have to test values using the f of x form. Then construct the table of values. And lastly, you have to graph the solution set on the number line. Do you have questions? If there is none, see you next time.